So hello everyone, welcome to another episode of Deep Dive Knowledge Talk. Tonight, we explore how latent semantic structures in vector databases unlock hidden business insights, discover how semantic embeddings like unsupervised clustering and LLM-merging centroids transform unstructured data. This empowers better decision-making, customer experiences, and market strategy. Stay with us. Can you explain the significance of latent semantic structure in the context of vector databases and why it is so important for analyzing business data?
Latent semantic structure is like uncovering hidden treasure in a vast ocean of information. When we talk about vector databases, think of them as big libraries where each book represents a piece of business data like customer feedback or product descriptions. So this data is transformed into vectors, which are like special codes that capture the meaning of the text, not just like the words themselves. The significance of latent semantic structure lies in its ability to reveal connections and patterns among these vectors. So, by grouping similar vectors together, we can identify themes or insights that might not be so obvious at first glance. It's like finding out that so many books in the library share a common storyline or theme, even if they use different words. For businesses, this is really important because it helps them make sense of large amounts of data by analyzing these hidden connections, so companies can discover valuable insights about customer preferences, trends, and even potential areas for improvement. So this strategic knowledge can guide decision-making, helping businesses to better serve their customers and stay competitive in the market.
Could you elaborate on the specific methods used for converting text into semantic vector embeddings and how this process actually aids in understanding the underlying meaning of the data?
The process of converting text into semantic vector embeddings is like crafting a recipe that really captures the essence of a dish. When we take a piece of text, we use a special model, so like the text embedding UDA002, to transform it into a vector, which is a series of numbers that actually represent the meaning of the text rather than just the word. Imagine you have a fruit salad made of like different fruits. Each fruit represents a word. But the salad as a whole represents the flavor or idea of the dish. So, similarly, the vector captures the overall meaning of the text, allowing us to kind of understand it in a deeper way. So there are different methods for turning these vectors back into readable text. One method uses a custom model to guess what the original text might be based on the vector. So another method skips this guessing game and directly combines information from the original texts associated with the vectors to create a new kind of summary text. This is like taking the fruit salad and blending it into a smoothie where you get a new, tasty mixture that still represents the original flavors. By using these methods, we can actually uncover the underlying meaning of the data. When vectors are clustered together, it reveals themes or concepts that connect them, much like how different fruits in a salad can share a common kind of flavor profile. This really helps us understand the broader ideas within the data, making it easier to analyze and draw insights from business information.
What kind of role does unsupervised clustering, specifically techniques like optics, play in grouping these semantic vectors? And how does it contribute to uncovering hidden business knowledge?
Unsupervised clustering, particularly with techniques like optics, plays a really crucial role in organizing semantic vectors into meaningful groups, much like sorting a box of assorted toys into different categories, just based on similarity. So when we apply this technique to the vectors representing business data, it helps us form clusters that reveal hidden patterns and insights. Imagine you have a big pile of really colorful building blocks. Each block represents a piece of information. So by using optics, we can actually group these blocks based on their colors and shapes, without needing any labels or prior knowledge about them. This is similar to how unsupervised clustering works. It organizes data based solely on its inherent structure. The main feature of optics is its ability to create a hierarchy of clusters. Just think of this as creating a family tree, where each branch represents a group of related concepts. The root of the tree represents the broadest concept, so while the smaller branches show more specific ideas. This hierarchical structure helps businesses see how different pieces of information relate to one another, uncovering connections that might not be immediately so obvious. By analyzing these clusters, businesses can discover valuable insights and knowledge that were previously hidden. So, for example, they might find that certain customer preferences cluster together, indicating a trend or an opportunity for targeted marketing. So overall unsupervised, clustering allows businesses to tap into the deeper meanings within their data, just guiding them towards smarter decisions and strategy.
How are cluster centroids calculated and utilized to reverse engineer descriptive text? And what advantages really does the merging of source text offer in this process?
Cluster centroids are calculated by taking the average of the vectors within a cluster, which is similar to finding the center point of like a group of stars in the sky. Each star represents a piece of information, and the centroid acts as a representative of that group, so capturing the overall meaning of all the members in the cluster. To reverse engineer descriptive text from these centroids, so one can use various methods. One approach, called vec2text, attempts to generate text directly from the centroid vector so. However, this method can sometimes produce nonsensical results, especially if the cluster contains just few and very different text. A more effective way is to utilize a technique called LLM-merging. So this method takes a frequency table of the original text in the cluster and combines them into a single centroid text using a language model. Think of this as creating a summary of a group of stories. Like, instead of trying to guess the story from the average of the words, you just simply summarize the main points from each story into one coherent narrative. The advantages of LLM-merging include speed and cost effectiveness. So it requires only one call to the language model and can produce meaningful text in just a few seconds. This is so much quicker and cheaper compared to other methods that might take longer and require multiple iterations. Additionally, LLM-merging tends to generate more coherent and relevant centroid text, making it a really powerful tool for uncovering the essence of the clustered data.
In what ways does the proposed method facilitate the discovery of hidden business knowledge, and what potential applications could arise from effectively utilizing this kind of latent semantic structure?
The proposed method facilitates the discovery of hidden business knowledge by transforming unstructured data into a structured format that reveals underlying patterns and relationships. Like when business data is vectorized, it allows for a more nuanced understanding of the information, so much like turning a collection of jumbled puzzle pieces into a clear picture. By using techniques like clustering, we can group similar vectors together, which helps identify key themes and insights that might be buried within sort of large data sets. This process can lead to various potential applications. So, for instance, businesses can analyze customer feedback more effectively, so discovering trends in preferences and sentiment. They could also enhance product recommendations by understanding which features or products are often mentioned together. So, additionally, this method can improve market research by identifying emerging topics or concerns within customer conversations, allowing companies to respond so proactively. Overall, effectively utilizing latent semantic structure can really empower businesses to make data-driven decisions, enhance customer experiences, and ultimately drive growth and innovation.
And so that brings us to the end of another fascinating discussion. A huge thank you to our audience for really tuning in. Today, we truly illuminated the critical role of latent semantic structure within vector databases, particularly for analyzing complex business data. So we explored how this powerful approach is really key to uncovering those hidden connections and patterns that lie beneath the surface of large datasets. We learned how transforming raw text into rich semantic vector embeddings allows organizations to pinpoint themes and extract meanings so far beyond simple keywords. The discussion highlighted the immense value of unsupervised clustering, especially techniques like optics, like in organizing these vectors into meaningful groups, revealing trends and opportunities without the need for prior labeling. And crucially, we saw how cluster centroids combined with innovative LLM-merging enable the quick and coherent reverse engineering of descriptive text from these data points. Ultimately, this comprehensive methodology empowers businesses to extract invaluable insights from their unstructured information, significantly enhancing decision-making, enriching customer experiences, and sharpening market strategies like this. So, thank you again for joining us. So we look forward to seeing you next time for another exploration into the cutting edge of technology.